Sequences that go from one term to the next by multiplying by a constant amount are called geometric sequences. For example, um, in the first case, we have 2, 10, 50, and 250. And we can see that this sequence starts with the 2 and increases by multiplying the previous term by 5. So basically, we can see that, you multiply 2 by 5 and you get 10. 10 multiplied by 5, you get 50. Multiplied by 5, you get 250. Now, this number 5, this constant is what we call the common ratio. Okay? In the second example, we have a sequence that starts at 8 and decreases by multiplying the previous term by a half. Yeah? So if you notice, 8 multiplied by a half, you get 4. Multiplied by a half, you get 2. Multiplied by a half, you get 1. And again, a half here is what is called common ratio. Okay. So what is this common ratio? The common ratio of a geometric sequence can be found by dividing any term in the sequence by the one before it. Okay. For example, 8 divided by 4 is a half. 10 divided by 2 is 5. And that's how you find the common ratio. So you can write this down. The common ratio of a geometric sequence can be found by dividing any term in the sequence by the one before it. Okay. And that's how you find the common ratio. Okay. How do we find the nth term of a geometric sequence? So, so suppose we are given the following geometric sequence. Of course, the first step is to find the common ratio. And we can see that the common ratio in this case is 3. And let's do some inspection. So by inspection, we can see that the first term is 2. The second term is 6, which is 2 multiplied by 3. The third term is 18, which is 2 multiplied by 3 multiplied by 3, which is 2 multiplied by 3 squared. The fourth term is 54, which is given by 2 multiplied by 3 multiplied by 3 multiplied by 3, which is given by 2 multiplied by 3 cubed. Now, what I want you to do is to do some inspection here and try to see the relationship between each term, right? And, try to find some pattern here, some connections. Now, we can see that each of those terms has a 2 before it. Now, let's look at powers of 3. We can see that, for example, the fourth term, the power of 3 is 2, which is less than that term, the position of that term. Yeah, because this is position 4, the power of 3 is 3. And look at the third term. This is position 3, the power of 3 is 2. Okay? And here, of course, the power of 3 is 1. So we can say, just by inspection, that the nth term of this geometric sequence will be 2 multiplied by 2 multiplied by 3 to power n minus 1. So 2 multiplied by 3 to power n minus 1. Okay? Because we can clearly see that the power of 3 is less than the position of that corresponding term in that sequence. All right. In general, if the first term of a geometric series sequence is u1 and the common ratio is r, then we can find the general form for the nth term. And we can use the same idea that we used in the previous video. So remember here, the first term is just u1. So we can just go ahead and say, okay, the first term is just u1, no problem. The second term is, remember, for you to get the second term, you have to multiply the term before it by the common ratio. So this will be u1 multiplied by r, which is u1r. The third term will be the previous term, which is the second term, u1r multiplied by r, which will be u1r squared. The fourth term will be the previous term multiplied by the common ratio. So the third term multiplied by r, which will be u1r cubed. The fifth term will be u1, the fourth term, u1r cubed multiplied by r, which is u1r to power 4. And again, by inspection, you can see that the power of r is less than the position of that corresponding term. For example, the fifth term, the power of r is 4, which means that the nth term will be the first term multiplied by r to power n minus 1. And that is the formula for nth term of any geometric sequence. Okay, so any geometric sequence, the nth term of any geometric sequence can be found using that formula. And I'm going to show you how to do that in the next examples. So, example 2, find the nth term of this sequence. So the first thing is find the common ratio, and the common ratio here will be 5, because multiply by 5, so common ratio is 5. Now we know that the nth term of any geometric sequence is given by this formula that we derived in the previous page. And by inspection, we can see that here the first term is 3 for this particular sequence. So what you are going to do is just to plug r and the first term into this formula. So the nth term for this geometric sequence will be given by 3 multiplied by 5, or we can use brackets. So the nth term will be equal to 3, 5 to power n minus 1. And this will be the nth term of this sequence. Next example, find the nth term of this sequence. And again, the first thing is to find the common ratio. So the common ratio, by inspection, you can see that it's negative a half. In fact, you can just find it by dividing any term by the one before it, which is equal to negative a half. So negative a half. Okay, so you have the common ratio. R is negative a half. We also have the first term, which is negative 24. And we know that the nth term of any geometric sequence is given by u1 r to power n minus 1. So plug those parameters in here. You have the nth term of this sequence will be equal to negative 24 into negative a half to power n minus 1. And that is the nth term of the sequence.